Hello, hello. It's been a while, but today we want to look at trigonometry. Okay, let me just orient my board. Okay. All right. So we'll look at trigonometry. And the first thing that we'll consider are the angles. You know, angles are very, very important in trigonometry because the ones that vote are the whole trig concept. You cannot talk about trigonometry if you're unable to interpret the values that you get whenever you meet an angle. So you must know what sine 30 is, what sine 45 is. There are so many angles, but then we have angles of our target, the ones that we call special angles. Those, they really help us in dealing with so many angles that are related to them. Okay, so I'll first mention the special angles. So we have 0, of course, degrees. Then we have 30 degrees. Then we have 45 degrees. Then we have 60 degrees. Okay. Then we have 90 degrees. Then we have 180 from here. Then we have 270. Then we have 360. So these are called special angles. And against sine and cos. So we have a very simple way of recalling what the values of sine special angles are by starting to count. So from 0 to 90, I can as well just do the counting 0, 1, 2, 3, 4. And then from there, I divide by 4, by 4, by 4, by 4, by 4. Then for cos, I'll do the opposite. I'll do 4, 3, 2, 1, 0. Divide by 4, by 4, by 4, by 4, by 4. This is just a way of helping us recall. So now you see what is 0 over 4? It's 0. Okay, so 0 over 4 is 0. 1 over 4 is 1 over 4. This guy is 1 over 2. And that is the same, and this guy is 1. So this guy is 0, and this guy is 1 over 2. The same, and this guy is 1. Then from there now, I get the roots. So the root of 0, the root of this guy, the root of half, the root of that, and the root of that, the root of that, the root of that, the root of that, and the root of this. So now after getting the roots, what we have? So now we have the root of 0 is 0. This guy is 1 over 2. This guy is 1 over root 2. This guy is root 3 over 2. Okay? And this guy is 1. This guy is 0. Now we get the root here. This guy is 1 over 2. This guy is 1 over root 2. And this guy is root 3 over 2. And this is 1. Okay? So that's how we get the values of these angles. Now, what's so important here is this was just a way of getting there. So now after you have the way, I can now come back and just drop the actual values. So I remove this solving I was doing here. I remove this so that I can put all the angles here. Necessary. Okay. So now, what am I doing? I'll get the pen, change the color. Okay, so we are saying sine 0 is 0. Sine 30 is half. Sine 45. Hey, how are you? Hello, Maud. Hi. Hello. Hello.
Hello.
How are you?
I'm fine, and you?
I'm all right. Okay. We continue. So,
Okay.
yeah, sine 45 is 1 over the root of 2. But if we rationalize this, it becomes the root of 2 over 2. Sine 60 is root 3 over 2 and sine 90 1. Now for 180, 270, and 360, you count them from 0. So 0 degrees, we get 0. 90 degrees, we get 1. 180, we get 0. At 270, we got negative 1. 360 is 0. So these, they just interchange. It's 0, 1, 0, negative 1, 0, 1. Okay. So for cos, this is 1, this is root 3 over 2, this is root 2 over 2, this is half, this is 0. So now, at 90, we get 0, so that we had negative, and then 0, then 1. So because this was 1, 0, then negative 0. Now, if I know the values of sine special angles, cos special angles, it means that I know all the values. Why do I say I know all the values? Because other trig identities or other trig ratios are defined using these. Okay, so before we talk about others, we also need to find another way in case I forget this table thing. How then will I know the values of sine or cos special angles? So we've got is it two triangles? So the first triangle is a triangle of this kind. Okay, this is the right angle triangle with a 90 here, and these sides are equal 45, 45. So now when these guys are equal, it means that the sides also must be equal. And via Pythagoras theorem, we know that if we add 1 plus 1, both of them squared, we get 2. And then we need to get the root of it. So now we're saying, okay, we know that there's SOHCAHTOA. We know that there's SOHCAHTOA. Okay, so we can get sine. So sine 45 is going to be opposite over hypotenuse. The very thing we said, if we rationalize, it becomes cos 45 adjacent, so which is the root of 2 over 2. Wonderful. So we could also talk about tan here if we want. So we'd say, okay, what about tan? Tan 45. Tan is opposite over hypotenuse, which is 1. But don't worry about tan and others who define them using sine method. Then also, so this angle is only given as 1. This triangle is only given as the values of 45. Then we can get another angle, another triangle is here. Wonderful. So this triangle is the triangle that has got equal sides, 60, 60, 60. But if we cut here, so we're going to have infinite sides because I've cut that one into 2 halves, and then it's going to have a 30 remaining this side and a 30 this side. Okay. Now, when the sides were equal, we had a 2 this side, a 2 that side, a 2 that side. Now that we have cut them, side becomes 1 this side, 1 this side, 1 this side, because we cut 2 into 2 equal halves. And then I need to find the middle side. The middle side using this is going to be 4 minus 1, which is 3. I then get the root. So I'm going to have the root of here. Okay, cool. So now we get back to sine 60 are opposite, which is over hypotenuse. Okay. What about cos 60? Cos 60 is going to be adjacent over hypotenuse. Okay. What about sine 30? Sine 30 is going to be opposite over hypotenuse. What about cos 30? Cos 30 also adjacent over hypotenuse. So now we know the value of sine 30, sine 60, sine 45. So if you know the mid ones, these ones, then you're home and dry because the other ones are 0, 1, 0, negative 1, 0. The pattern doesn't change. 1, 0. So if you're starting with 0 for sine, you go to 1. And then 0, then to negative 1, then back to 0. If it's cos, you start from 1 and then to 0. So you can't jump from 1 to negative 1. It's 1 to 0. Now, because I'm moving from 1 to 0, I must go to negative 1, then 0, then 1. So the pattern doesn't change. It moves just like that, which is a cool thing. Okay, so then we can expand the talk to other ratios. So we're saying we haven't talked about tan. Yeah, because we know that tan is just sine over cos. We haven't talked about sec because we know that sec is 1 over cos. About cosec, because cosec is sine. About cos, because cos is cos of sine. Better still, cot is 1 over. So these also can help us. Instead of having all those things listed on the table or having triangles that gives us those values, you just need to know for sine and cos. When they ask you for tan, you divide the values of sine and cos. But if I'm using the triangles, I can just go straight to the triangles and say, okay, tan I know is opposite of adjacent. But if they ask me about sec, cosec, or cot, I just use the 3 that I know. 1 over sine, 1 over cos, 1 over tan, that's all. So quite cool. Okay, let's look at an example now. We get the example from the question 1. It's our first example. So it says copy and complete. So we copy. This is theta. This is sine. This is cos. This is tan. cot, sec, and cosec. All these are theta, 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 theta. I don't know why. Okay, and then negative 3 pi over negative pi, negative 2 pi over 2 pi over 3, negative pi over 3, 0, pi over pi over 3 pi over 3 pi over 5 pi over 6. Okay, now we're talking about pi's, and then we are from talking about degrees. So what's the relationship between a degree and a pi? So we know that pi is equal to 180 degrees. So if I'm not comfortable dealing with pi's, I just move to degrees. So like 3 pi over 2, to convert it to degrees, we multiply by 180 over pi. So that this pi and that pi will cancel. And then 2 here, 1, 2 there, 90. 90 by 3 is 270. Now, we say that our sine 270 is equal to negative. From this side, sine 270. Right? So, if sine 270 is negative 1, then what is sine negative? Okay, what is sine negative? So this area that it can put the it remains, the angle remains positive, and then the sign goes, the negative sign goes outside sign. So it becomes negative sign 270. But not that sign negative. So we put a 1. Huh? What about sign 270? So sign negative 5, we know we do the same, this will be negative 180. So that we get 0, which is 0. This guy is 0. What about 2 pi over 3? Again, we convert it. This will be 2 pi over 3 by 180 over pi. So this cancel. This here, 6 by 2, that's 1. Now, what is sine 1? Okay, so sine 120 is related to the angles that we call reference angles. So we have a set of angles that are called reference angles. How do those angles help us? Maybe let's get to this board a bit. We talk about the reference angles. What are reference angles? So reference angles are the angles that we find in each quadrant, responding to the angles in the first quadrant. So I have these 4 things I'm going to talk about, whereby this is the second quadrant, third, and the fourth quadrant. These quadrants are holding the angles in the first, so we call this angle theta. A reference angle in the second quadrant to that theta is going to be the angle 180 minus theta. So we want all the reference angles be between 0 less or equal to the theta less or equal to the theta which is less or equal to. So what the reference angle be in this region. Okay, so here we'll say, okay, this is going to be theta. So let me do the opposite. Let me make it this way. Since I'm doing it this way, this should be our x. Yeah.
Is there 90 in the first or the second quadrant?
90 is the boundary.
But it's where?
It's on that shows you that the first quadrant has ended here. The second is starting. So it's neither in the first nor second.
Oh.
Yeah. So now we want these x's, we want the x to be between 0 and 90 always. So how will that happen? Whatever angle I'm given as theta, for me to find its reference angle, I subtract. In the second quadrant, we do 180 minus that theta given. In the first quadrant, we do x theta minus 1. In here we are doing 360 minus theta. Because the boundary is 360, 270, 180, 90. So the 270 does not appear in any of the calculations that we do. Because we only want to talk about the angles that are leaning on the x-axis. So if they ask me for a reference angle of theta, then the reference angle of theta will be theta itself if that theta belongs to the first quadrant. But if theta is in the second quadrant, then for me to find the reference angle, I'll subtract 180 minus that theta. If theta belongs in the third quadrant, then I'll subtract that theta minus 180. If theta belongs to the fourth quadrant, then it will be 360 minus the theta.
I've got a question.
Yes.
What if theta is 90?
If theta is 90, they won't ask you for its reference angle.
Huh?
Nobody will ask you to find its reference angle.
Okay, then for the third quadrant, I saw somewhere where it was 180 plus theta.
It's 180 plus?
Plus theta.
It's when, that one is when you want to get an angle that lies in the third quadrant.
That lies where?
In the third quadrant.
Then this one.
This one is giving us a reference angle.
Okay.
The smaller reference. Because look at what I've put the reference angle. They have said, I want to call the smaller angles reference between 0 and 90, right?
Mm-hmm.
So I cannot have an angle that is between 0 and 90 being gotten after 180.
Yes.
Yeah. So you see when that happens. Now, why do we need reference angles? So for 90, you wouldn't be worried because you know the value of 90. Say find 90, you know the value. So that's why it's not so important to talk about to talk about the angle of 90, because we know the value of 90. Here we want to try to find the values of the angles which are not special angles. So now we want to find the value of sine 120. See? But we don't know what sine 120 is. 120 is not a special angle. Not on the table. It's not in the angles. So what do? We look at where do we find 120. We find 120 in which quadrant? 120 is in the second quadrant because it's above 90, but below 180. So now we want to find it. So we'll say 180 minus 120. What value do we get? It is 4. So now, one more thing remaining. This sine, cos, and what are their signs in each quadrant? In the first quadrant, sine and cos, these guys are positive. Or if these two are positive, then even cosec is positive. Even tan is positive. Even sec is positive. Even cot is positive. But in the second quadrant, only sine is positive. That means even cosec will be positive because cosec is 1 over sine. The other angles I mentioned are negative in there. In the third quadrant, only tan is positive. When tan is positive, then even cot is positive. In the fourth quadrant, cos is positive. When cos is positive, even sec is positive. Then the others are not positive in those quadrants. So now we've said sine. We're looking for sine. We're looking for sine. So the value of sine is the same as the value of sine 60, because the two 60 is the reference angle of 1. That means that these guys are going to give us root 3 over. Now we've said the same because 60 is in the first quadrant, 120 is in the second quadrant, so where sine is positive. So we won't have an issue of positivity. Okay, for that one. So now we go back to our table. We have found the value over 2. The fact that this guy was obviously sine goes negative will go out. And then negative pi over 3. Pi over 3 is 1/8 over 3, which is so simple. Pi 60 is root 2 over 2. So we'll have.
Why is it negative?
Because when we take it, the negative will go out.
Or because of the negative 120?
Yeah, because of the negative 1. So the negative will be outside and then the negative is positive.
Okay.
Yeah. And then sine 0. Sine 0 is 0. Sine pi over 4. Pi over 4 is sine 45 will be over 2. Sine 90 is. What about 3 pi over 4? What is it? That's 3 180 over 4. And that's here 1. Here it's 45. 45 by 3 it's what's 45 by 10? Okay, 45, 90. 135. So we need the difference angle for 135, which is 180 minus 135. That will be 5. That's 45. So 45, we know that sin 45 is equal. And then 5 pi over 6. What is pi? Just put 180. And then we have this is 30 here. By 5, that's 150. 150, the difference angle is 30. So it's half. So that's for that's for sine. So we need to do the same for cos.
Or negative pi over 3. Isn't the answer supposed to be negative?
Yeah, it's negative.
Okay.
All right. Okay. So now, how do we find cos then? Cos has got a different property opposite from sine. Cos negative 27 is the same thing as cos 27. Cos does not bring the negative out. It makes it positive. So we then have what is 270 from the table? 0. And then cos pi, what's cos 1?
Negative 1.
Negative 1. What's cos 2 pi? 2 pi over 3. 180. 360. That's 120, right? Yeah. So what is cos 120? Let's go back to the quadrant to see what happens. Yeah. We're not talking about cos 120. So cos 120 should be equal to cos 60. But 60 is in the first quadrant. 120 is in the second quadrant where cos is negative. So you put a negative here. That negative now comes from the change of quadrants. From second quadrant to first quadrant. In first quadrant, everything is positive. So the only way one knows out the sign when we use an angle of the first quadrant is by checking that negative. Okay. You get that?
Yes.
Good. So whenever you're moving from where cos is negative to a quadrant where it is positive, the negative must come. So this is going to be negative 1 over 2. So we come here, we put a negative half. And then pi over 3. Pi over 3 is 60. Now cos negative 60 is the same thing as cos 60. So it's going to be half. Okay. Cos 0, 1. Cos 45, root 2 over 2. Cos 90, 0. 3 pi over 4, what was it? It was 45. Was it 45? gesture. This is 45. 45 by 3, that was 135. So 135 is in the second quadrant. And so we are getting 45, so it means that this guy is going to be negative root 2 over 2. And then 5 pi over 6, that was 150. So 150 is in the second quadrant. Sine 80, that is root 3 over 2. Okay. So now, for tan, cot, sec, cosec, no more calculations of angles. We just divide the numbers we have. That's all. What's tan?
Wait, there it's 135.
You see?
135 on 3 pi over 4.
Yes. It's 135.
Oh, I had 45.
No, it's 135, but then 135, what's the difference between 135? You subtract from 135. To get 45.
You either do that or 135 minus 180.
No, it's 180 minus 180.
Isn't it in the third quadrant?
135 is in the second quadrant. Bigger than 9, less than 180.
I mean cos.
The cos is in every quadrant.
Hmm?
Look at
Where
this.
it's positive.
Where's You're confusing yourself. We don't care about where cos is positive or negative. Our interest here is what angle are we dealing with? We're dealing with 135. So where do we find 135?
Second.
Second. So we go to the second quadrant and get its reference angle. So
We did the same thing for 120.
yes, that's how it goes. So now,
Okay.
then we are now 145. The question is, where is what is the sign of it's negative? So that's what you get it?
Yeah, not audible.
So I was saying that after getting 135, then you check now, since you want to use 45, which is a reference angle of 135, you check where 135 is coming from. 135 is in the second quadrant, where cos is negative. That's the reason why we put this negative on cos 45.
Oh.
Why didn't you put a negative on sine 60? On sine 60?
Because the sign is positive in
Where?
the second quadrant where 120 is.
Correct. So now we come back and now we have a negative root 3 over 2. Then now for tan is sine over cos. So obviously undefined here because it's 1 over 0. Here it's 0. So you can just keep dividing throughout. For cot, you divide cos over sine. For sec, 1 over cos. For cosec, 1 over sine. Then you fill up the whole table.
Okay.
Yeah. Okay. I think that's fine. Now, what has been the problem? Okay, let's do question 2.
Yes.
What are you doing?
Question 2. I know it.
Okay, good. Question 3.
Mm. Question 3, I know some.
How
But
do you find
for the ones like, hmm?
how do you find cos 75?
Cos 75,
Mm-hmm.
you do 60 plus, I mean 30 plus 45, and then
Then,
you use that formula for cos alpha plus beta.
all right, correct. So then you can do everything there.
No, for this one which has like 165 or 105, I don't know how to go about those.
You don't have two numbers you can add to get 105?
Or for 105, it's 60 and 45.
Uh-huh.
Then for 165,
165. It's 180 minus, wait, 165. 120 plus 45.
but 120 is not a special angle.
120 is here. It's a special angle through 60.
So 120 and 60 are the same.
They are special angles. The only thing that will be differentiating them is a negative. If you are dealing with cos, your 60 will be negative.
Mm.
Mm-hmm.
So I should write 120 plus.
Plus 45, and then
45.
use the identity.
Then where I write tan 120, I put the tan for 65.
You put what?
The tan for 65.
For 60.
Oh, for 60, I put root 3.
Yes. Because over.
Okay. But can you solve one so that I see how you do?